Hi everyone, we're going to pick up where we left off last time, looking at inheritance, and I briefly went over what linked lists are again, just so we can look at the code. Again, this is me improvising this code, so unless it goes really off the rails, we're going to find out whether I can actually code something. We're going to see all the mistakes that I make on purpose, because I know I'm going to make some mistakes. That's okay. The point is, if I give you a perfectly immaculate way of coding something, we don't hit those cases where I try and deduce what's going wrong with my code and I actually troubleshoot my own code. Given the circumstances, I want to make sure you see how someone could actually go about deducing what's wrong with their code. There are times when I may want to pause the video because it's terrifying to do this in front of an audience, but it's just to point out that it's not something that naturally comes and it's always going to be perfect the first time you write it. Some of this will take iterations, it will take time, and it will take testing and writing a little bit of code at a time and building up from there versus trying to write everything at once and then testing your code. It also involves thinking about your code before you dive in. So, here is our general idea. We have, instead of a normal linked list, which we had before, which had every single node had the next a pointer to the next node, and so n2 has a pointer to the next node, n3 has a pointer to the next node. There's a chunk of this that is, I can't even probably draw on it well enough. There's a chunk of this data structure that, let's just put it right on, oh, that's not going to work very well at all. Let's undo that. Although I think I make more errors in my slideshows than I do, and that's not even showing up. Oh, there we go. Stupid PowerPoint. I don't know what's going on here, but it's like a rock concert, so we can have fun with that. All right. A chunk of my, when I'm making this new doubly linked list, wow, that's flickering a lot. When I make my doubly linked list, what I'm going to have is I would like to keep all the code, or as much of the code as I can, from the previous linked list data structure and just add a little bit, right? I need to add these previous pointers as well to know where the previous element was. That's going to be almost the same thing, except for there's going to be some changes, some things that I may not predict along the way, like that this thing is going to flicker so much. This is insane. Um, Number two thing, I'm going to make a brand new data structure for a doubly linked list, a delinked list instead of linked list data structure. It's going to be a child class of linked list. The only difference between those two is that I'm going to have to keep track of the end pointer, this one here, n4 in this case. And I'm going to try and reuse as much of this code as possible. That does mean I might want to change some of my parent class. In fact, I did that. So let's just get out of this before I get I get freaked out by all this flickering lights. And let's go into linked list demo of this new linked list demo thing. All I've done, so I took my old code, LL demo new. All I've done for this thing is I took my old code that I had, copied the folder, and opened it out again. And I just renamed the name of my project. Let's actually see if it's the name of the project. In class code, LL Inheritance. Okay, so I'm going to rename this thing as well. L10 LL Inheritance. Tense. Oh, I'm going to ents. Okay, we have a linked list. We have linked list node. We have linked list main. That's all. Those are all fine and good. I'm going to rename this as much as I can. I want to sort of keep some consistency. Even inconsistent spelling if I had spelled inheritance wrong. I wish I had spelled checkers on this sort of thing. So here I have my linked list node. It should work the exact same way as my last one did. I'm going to just compile it, make sure that it does work the way it did last time, just to be on the safe side. It may not. I added a couple functions, so that's why I'm pointing this out. Here is the new code that I added. It's very, very impressive new code. I have a function that checks what gets the start. I didn't have that before. I have a function that gets the end. Very, very fancy stuff here, right? Now we might want to make those private functions. So let's do that. So here I am in linked list. Let's make sure my new functions here. I'm going to move those. Right now they're in the public. We can make them private. Actually, I want to make them. We'll see this in a second. And by the way, there is a formalized way of doing this normally. I think it ends up most people do this. I blank on it, look it up, or look at other people's code for myself. You just want to have some rhyme or reason on how things are put down, depending on how you want to view things. Some people put all their member variables at the top and then their functions later. Some people do public protected private. Some people do private protected public. You just want to have some kind of consistent structure for how you do things. I like public because public is what everyone looks at first. It's all the functions you have available to you. And if you're still reading, okay, there's some things that you might use in a child class. Oh, and here's the stuff that you shouldn't even know about down here. I don't want people to have pstart directly. I want to encapsulate this, so I want to have some kind of method that I ask for the start. Now, if I have a linked list node, or if I have a linked list, I might want to get the start, but really what I want is I can either get the start or I could get a particular element. I might want a function that finds a particular element. But to know that I have a start and an end, eh, actually let's put those up in the in I'm going to put those in public just because I think those are useful functions for other people to be able to get access to. No, I don't want that. Never mind. There's a reason. What I might want is get the first element or first data. I might want to find a way of getting a particular element based on an ID, but nobody should actually know that my linked list has nodes inside of it. What's a node? I don't know, but now you need to know. What I want is something like this, either the linked list data or whatever kind of data I'm storing in my linked list. That I should return. Maybe get the first instance of something, maybe find something in my linked list, maybe return the very first element, first data structure from that thing. I might want that in my linked list class, but passing around what a node is means the other classes that are using that code need to know what a node is. They have no need to know how this thing was implemented. I want it to be some magic box that stores crap. Right? I don't want to know exactly how it's implemented. Other people shouldn't know how it's implemented. I don't know how the engine of my car works necessarily. I just want it to run. So any function I make public, it's if you're going to use this thing, you better need this thing. You don't want to give gory details about something. If you're wondering where things get where you might see something like gory details in computer science, they're everywhere. We're really bad for this. The reason the Mac is so successful, Apple's so successful as a company, is because they kept on hiding the gory details. When you need it, you can find out, but they don't force you into it because this used to be CMD, right? This used to be the standard, and then you'd have dir, and then you have a bunch of stuff here, and then I have chmod, and then I have all this kind of stuff, right? I get a big pile of crap thrown at me, and I'm supposed to figure out what the heck all of this stuff does, right? That's what we're trying to avoid. We don't want other people to know how a linked list is made. We want to just have them use it. Okay, so I need to make a new linked list node. So DLL node, and it's going to extend from linked list node. Beyond that, there's a reason I needed to have this start and end. Where is start and end? Here is start, here is end. Because I'm going to replace this get end with a new version of it, or maybe I want to keep this old version around actually. But I need to be able to get the last node in my linked list. I need to be able to get the first node in my linked list. That's going to be useful in general. Um, and so like I might want to I'm trying to reuse as much code as humanly possible. My doubly linked list, what's it going to do? So let's think about how I wish I could draw on my screen right now. Let's think about how a doubly linked list is supposed to work. I can go back to my my slideshow just to point out what it looks like again. I have my linked list nodes. They all point to the next, each one points to the next one. I just point to the start. That's what I originally have. And now what I needed to do is also have a previous, previous, a previous. I need to hook those up when I'm adding things. So when I add a new linked list node, I got to also worry about the previous. And then I also am going to need to worry about finding the endpoint. Okay, so this is my thought process on this. I'm going to need a previous. I'm going to need to be able to set the previous for any given doubly linked list node. So let's go into this. So I'm going to make a brand new class and a DLL node, and the base class, I can say this, we've not used this before. The base class is going to be LL node, right? I know that this thing exists. It's in this project with me right now. It's going to have public. We won't worry about the public access to it. Just leave it as public. And it's going to make a header file called DLL node and a CPP file called DLL node. Let's make this thing. Okay, what do I have here? It's going to include this once. I'm going to, this is the header file, by the way. I'm going to include I'm going to include llnode.h because that's where I'm getting the parent class, right? This is what inheritance is going to look like. I'm going to make a brand new class called DLL node, and it's saying, and use LL node as the parent. Take everything from LL node, keep it like that. In fact, let's save all. I should have DLL node around here somewhere. It does a grand total of nothing. Great. And everywhere in my linked list class, I'm going to, what I could do for my linked list class here is just, if I compile it, it should just compile, first of all. Great. If I made in my linked list class, if I changed LL node to DLL node everywhere, nothing is going to change. Other than the names of the things, I made a child class, but the child looks identical to the parent right now. I have not added anything extra. I get everything from the parent. I get all the characteristics, all the functions, all the member variables from the parent. And then I just, don't do anything. So let's do something. That would be crazy. What am I going to need here? So this is DLL node H. Here we go. So I'm going to make a private variable, and then this is going to be DLL. Here's where the issue is going to resolve, or be where we're going to have an issue. DLL nodes, and I know we are going to have this issue because I hit this issue last term. DLL node, I will have a next, which is just an LL node, not a DLL node. And I'm going to have a previous, which is a DLL node. And we can get into weird cases when I don't know the thing that I'm going to next, if it is a LL node or DLL node. I don't know if it's a special case of linked list node or if it's just a linked list node. There's no way for me to know. And therefore, there's no way for me to know if I can call previous. When we do polymorphism, we will be able to know this. But until we do polymorphism, we gotta, I don't know, something happens over there. Okay. I'm also going to need maybe set my previous. So void set previous, and I will have a DLL node. We'll use this pointer for this. I have a pointer with the same name as a member variable. I'm going to need this pointer to differentiate between the two. Just, I want to show this in action again. I can get the previous node, so DLL node, get previous. That would be useful. I'm going to need, do I need a constructor? I should have a constructor. So I'm going to have DLL node, and it's going to take in int ID. We're going to see something a little wonky here. Well, actually, we'll see it in the very, very soon. I'm going to have a new constructor. Do I need a new destructor? Well, let's look at linked list node and see what we have. Actually, I probably do not need a new destructor at all. In fact, I do not have a destructor at all on linked list node. The linked list itself has a destructor, I think. Okay, so yeah, that should do it. Great. Let's see if there's anything else. I might have other things I need to do, but I need to implement these things for sure. Uh, so let's go to double linked list node.cpp. Let's fire all of these things in. There was only two functions. One, two. Oh, the constructor. All right, and then I need to put this in the front every single time, saying where in in the class DLL node, I'm implementing set previous. In the class DLL node, I'm implementing this constructor. All right, that's what we're doing here. Here is where things are going to get a little wonky. We're going to see, if we haven't already seen an example of this, I don't think we have, we're going to see this, which is I need to call the parents constructor. So we're going to take on faith for right now that we're going to call linked list node ID. And then p previous is equal to null. Right? When I make a brand new linked list node, and why is that not? Let's see. Well, you should include the standard out. DLL node. I want to see what the heck's wrong with this thing here. If this is going to include linked list node, linked list node should have, I thought, I'm going to put almost everything in linked list node. Let's look at this one. Linked list node. So why is it that this thing, I want to get rid of this IO stream here. There's a reason I want to get rid of this IO stream. I'm going to put this all the way in linked list node up here. If I include linked list node, which I need to for every one of my classes, I can put in the IO stream, and then I don't have to worry about, oh, well, on Tuesday I need to include this one. No, I'm just going to include it everywhere, because all of them are going to need this null. Now, I could have done things better and just defined null, for example, or done something else. That would have also been fine. Let me see here. Linked list main. Let's also put my assert in there. So this is actually one very standard approach for if you ever get stuck on dealing with header files. This is one standardized approach you could take, which is you have one file, one header file that includes all the header files you're going to need. So every single header file, so every single class includes that one header file. Every single CPP file includes that one header file, no matter what. And then you don't have to worry about like, oh, I forgot it, or oh, I have to worry about what order I do things in. We're not doing exactly that, but that is one approach. So I can include linked list.h, I could include linked list node, I can include double linked list node, I can include everything in one header file, and then every single CPP file just includes that one header file, and then therefore includes all header files. It's just an approach that you could take. Otherwise, you have to worry about like, oh, well, this is compiled before this thing, which gets compiled before this thing. It's a pain. Okay, so let's have a quick look at this thing. I have this linked list node. I have getNext. I have isEnd. I might want to override isEnd, but that might be something for a later time. SetNext, getNext, print the node itself. Maybe I want to override the print node thing. We're going to look at overriding soon enough. For right now, I'm going to leave as much stuff alone as I possibly can, and then we're worried about overriding it. Double linked list node. All right, and so what I want is this p previous is equal to p previous. Why? Because I have two things named p previous. I have a local variable named p previous. I have a member variable named p previous They are different values. They are different variables. They both have the same name. It's two people both being named David. It leads to confusion, right? I'm sure many of you, unless you have a really atypical name for wherever you grew up, you grew up with somebody with the same name as you. May not be the case. Davids are a lot less common than they used to be, but there are two David, not Dave and David, no, two Davids in this department right now, and we have to go with David S and David T. There was three Chris's for a while, right? It When you have duplication of names, it's a pain. So how do you find context? The person, if you're talking to uh, a particular person, or you're talking about administrative stuff, and you say Chris, you probably mean Chris Jocelyn, right? It's based on the context. The context here is, if you have a local variable named previous, that's the one that gets the priority. That's the one you're probably talking about. So if I want to be talking about the member variable, I need to say, yes, this object I'm dealing with, the member variable for this object. And this one was, by default, I get the local variable. So using the this pointer allows me, not only if I forget the name of things, it gives me a nice little handy dandy, here are all the various options, but it also allows me to disambiguate the issue. So, and this is going to be return p previous. There's no local variable named previous, so it must be the member variable, the part of the object that I'm dealing with. All right, that should compile. I hope. Nope. There we go. So what's going on here? Can I convert argument 1 from int to LL data? Oh, let's have a look at linked list node. Oh, it's not an ID at all. It's a linked list data, isn't it? Let's go to I'm going to go to linked list node. Yeah, there you go. It's the data. I'm not including an integer. I'm including data, whatever that data ends up being. Whatever we define this data structure to be. In this case, it's just some number. It's going to be an ID. So I'm including the data I'm going to be storing in here. My linked list nodes could also have a unique ID. You can implement it 1,000 ways. There's not one way of doing this. I'm going to need to go to wlinktlistnode.h. I need to change this. It's not an ID. What am I thinking? It's just the data. I want to have the exact same constructor as the parent. So what am I going to do? What's going to happen here? And let's also do this. Cout calling DLL node. I should also use namespace std. Just so we don't have to put like std : cout, std : end line. Depends on how you want to view things. Or actually, we could keep that in there. We can keep the other way in. Here's the other way of doing it. std : std : saying, in the standard libraries, look for end line. In the standard libraries, get me the cout. That's all we're doing there. I want to do one more thing just to show you this in action. I'm going to linked list node, and in my constructor, just for fun, I'm going to plop that in there. I also want to see what happens here. P next is uninitiated. All right, we forgot a variable. So this, what's the name of this thing? Oh yeah, it's P next. Okay, I want to set it to something. Let's see if that gets rid of that warning. Does it get rid of the warning? Is P LL node P next is uninitiated. I did do that, so let's move this stuff over. First things first, before I do a cout statement, let's initialize all my variables. All right, so let's have a look at this again. I haven't really done a lot of changes to my code yet. I have a brand new node called a doubly linked list node. I'm going to make a brand new linked list called a delinked list. Why? Because it needs to be able to know about whether I have a previous or a next everywhere. So I'm going to add a class, and hopefully this is going to work. And its parent class is going to be linked list. Okay, public, that's fine, that's fine. All right. So I have a new doubly linked list class, which is just exactly the same as the child class, the parent class, right? If I compile it now, nothing changes. In fact, now I can actually show you this in action. I'm going to go to my linked list main, and everywhere I'm going to put a D doubly linked list, and that should hopefully do it. Let's see it. Hopefully it builds, and it builds. I didn't do anything in doubly linked list. All I did was say it's the same as the parent class. Well, it's the same as the parent class. There is no new code, so everything works the exact same way as the parent class. For the most part, we'll look at private, protected, and public very soon. Okay, so what do I have in my linked list class? I have a constructor and a destructor. I might need that again, or I change those up up a bit. I can insert at the front. I can insert at the back. Might need to change that again. Um, and I also need to remove. I can remove from the front, remove from the back. Might need to change those. Checking to see if something is empty. Do I need to change anything? No, I don't. Don't need to change it at all. In fact, that's the point. If it's empty, I have an element. P start is equal to null, or it's not equal to null. That tells me if it's empty or not. Printing off the linked list, I might want to override that one, change it up, but I don't think I can right now. So, and I can get the start node or the end node. In fact, I shouldn't even be doing this. I should get the first and the last, the start and the end, and instead of it being a, what is this? Get start, get end. Let's look at link. We should look at like linked list main now. There it is. Insert it back, insert it front, print. Those are protected methods. Actually, that's still fine. Okay, those are protected methods, as in the main method's not going to call it. So we're still doing fine. What I'm saying is what protected does is it says any child class of mine can still call get start and get end. If I need that, it's a useful thing to have around. And so protected means your children have access to it, friend classes have access to it, but random other classes don't. It's a halfway point between, and it's very similar to if you know chmod. Many of you don't, but if you're doing anything with Unix or Linux and read, write, and execution access, you have the user or the owner of the file. You have people that have higher access, like friends or administrators have access to the file and what they can do, and then there is the general public, what they can do with the file, and that changes who has access to that particular file. Well, it's the same thing here. Who has access to this function? This is everybody and their dog. This is me and my children. This is only me. So that's why I need get start, for example. Here's where we're going to get ahead of ourselves yet again. I'm going to try and implement some of these things in doubly linked list.h. So here we go. I'm going to need a new kind of constructor, a new kind of destructor. The destructor is always going to call the parent destructor. We'll see this in action. Inserting at the front. Do I need to do anything special about inserting at the front? I might. I need to know if the thing I'm going to be adding, the data I'm going to be adding, where it's going to be inserted. So I might actually want to re-implement that thing altogether. So I'm going to keep that. Inserting at the back, I'm pretty sure I'm going to have to re-implement all of that again. Removing from the front, removing from the back. That may all be stuff I need to re-implement altogether. Is it empty? well, I need to figure out if something, I need to get whether something is empty. That actually should be the same both versions. So that should be fine. And I'm going to just comment out the print because I'm pretty sure I'm going to need to re-implement that. Get start, nothing's going to change, so I can get rid of that. I'm going to use the parents version of it. Get end, actually I'm going to use the parents version of that too, but it's going to be for a different reason. No, get end, I'm going to implement it myself. Okay, the reason I want to do get end on my own is I might need to find out if the end, I might need to be able to call the parents get end, but my get end, I should have the endpoint. It should be in there somewhere. So uh, let's look at linked list.h. Hey, I have this private variable. Let's make a new private variable. And this is going to be p end, right? I needed a start and an end with a doubly linked list. That was the other part that we were talking about. And so all get end is going to do is just going to return this thing. For a linked list, I got to walk down my linked list. Right now, I just say, yeah, just get the pointer to the end. We're fine. So it's useful in that way. I'm going to also make sure it's a doubly linked list, but maybe that might be a problem. And we're also going to include doubly linked list node.h. Okay, my linked list, my doubly linked list, where is it now? I haven't opened it yet. Okay, so I have all of these functions that I'm going to need to implement. They're going to use very similar things to what I've already implemented. So it's going to look very similar to what I had before. In, actually, I probably should. What's the fastest way of doing this? I'm just going to go to linkedlist.cpp and just copy all of that stuff over and then modify it because I'm lazy. So here's just pure laziness on my part. Okay, linkedlist.cpp, and hopefully it's not going to bite me. All right, everywhere I have a linked list, I'm going to put a doubly linked list. Doubly linked list. And as I said, we're going to call the parents version of this. So I'm just going to call I'm going to call linked list and then pass in nothing. Okay, my destructor is going to be the exact same thing, but I don't need to do anything at all with this thing. I'm going to have we'll look at this in a second. I do want a couple things in here. Let's see what I did with doubly linked list. I did doubly linked list node. I did this. So let's just drop those in there and see what happens. Calling constructor, calling d, call it doubly linked list destructor. I'm also going to put this in my linked list. Just I want to see what the order of things are because I think it's going to make a difference. So calling linked list destructor, calling doubly linked list destructor, we can figure what order these things are going to be called, and if we call the parents one, that sort of thing. So we can deduce what the heck's going on with this system. When I make an object, what's the order of constructor calls? When I destroy it, what's the order of destructor calls? Okay, here's the new code. I said I had new code. I'm going to get rid of this one. I'm going to get rid of this one because I want a doubly linked list. And all I'm going to do, return p and done. That's it. That's all I need to do for get end. Just say, oh yeah, what's the end? right, and pass it off again. Inserting at the front. Oh boy. So inserting at the front, I'm going to need to do almost the exact same thing as I did before. I may not be able to do the crazy things I did in the past. So I'm going to make a doubly linked list. It's the same as it's a kind of linked list node. So a doubly linked list node is a kind of linked list node. I'm going to check to see if I do have a start. If so, I can't call this, but I can call get start. If get start, so if that's not equal to null, um, and I have a node that I'm going to be adding. I'm going to add the start to this. I'm going to, so I want to actually keep around. We're going to get a little bit weird here. Oh, let's just do it that way. All right, but notice it's going to give me an error. It's giving me an error because it's saying, hey, you're not getting a doubly linked list node pointer. You're getting a linked list node pointer. But you should know better. Like when we're doing this, every time I insert a new thing, I'm going to be making a doubly linked list node. It doesn't know that it's a doubly linked list node. So it's like saying, I have a bunch of Carleton. I'm going to have a group of Carleton students, but they're only BIT students. I'm asserting that I'm going to be making a list of BIT students, and the list just says no. I just know I have a list of Carleton students. I don't know they're BIT students, so it's yelling at me. I can say no, no, no. I know better than you. I know that they're they're BIT students, not Carleton students. So I can actually put in. I could cast this thing like we did with malloc. I'm going to cast it. Say no, no, no. I know better than you. It's a doubly linked list node, not a linked list node. So here we go. Start. I can go back to this thing. Uh, I need to, I'm going to set the next to p start. So I have a brand new doubly linked list node element. I have the start. I'm also going to say p start and set. I don't want to say set previous. Why don't I have a set previous? Doubly linked list node. Set previous should be in there. Let's have a look at this thing. Why isn't set previous showing up? I have set next. I have the start. If p start, I should have set previous. That's not even a question of what, if I should have it, unless this error is something going wrong here. Two overloads cleared. It's inaccessible. So I want to see what the heck's going on here. Doubly linked list node has doubly linked list .h, so that should be fine. I'm going to have to go through this again with a fine-tooth comb soon, because what I need here is set previous. Oh, so it's starting to work at least, and then it's going to be p to add node, because now that I have two pointers, I will have these weird situations where before I did it by just hooking on a pointer. Now I got to hook up the point previous and the next. They got to hook up to each other. So we can't just use the code from the parent class everywhere. So if that's the case, I want to do this. I can also set start. Don't have a set start in linked list node. I have a get start, not a set start. All right. So since I have to modify that anyways, okay, I'm going to have to make a change. So hopefully a small little change. Void set start and linked list node. So I'm going to have to add this because otherwise it doesn't even know that there's, unless I make this thing public, which I don't want to do, I need access to this variable right here. Now, if I put that variable as protected, absolutely, I could just modify that variable directly. That would be fine. So that would be another option that I could do. Instead of using a set method, I could just make that protected and just do that. But I'm going to choose to use a setter method. I'm going to go to my linked list, this thing here. I have a section called new code, so let's just plop it down in there in the new code section. Okay, so void linked list set start, and then this is linked list node p node. I'm going to make the linked list node thing set start is in protected, so no one has access other than the child classes. Okay, so I want to make I can do this set start and p to add node, and that will do it for me. Essentially does what that thing here does. Don't know who the heck that is. Beyond that, what else do I need to do? So I've set up my starting point. I need to know that the new node I'm going to be adding points to nothing. The next is also pointing to nothing. That's fine. When I add this new node, I set the next and I set the previous, which was what was my start. So that's what I would need to do for this. If I insert it at the back, I need to make a brand new node. It's going to be, again, a doubly linked list node. I could get the current end that I have. Wait, I already have the end. So my doubly linked list node I'm going to say it's going to be a doubly linked list node. I know it's going to be because I'm dealing with a doubly linked list node. I just need to get the last element. So if there is a last element, I'm then going to set the next to the new node I'm going to add, and then I also need to set p to add node, set previous, and it's going to be p end. I got to figure out what the heck's going on with set previous. Otherwise, if there is no endpoint, it means really there's no starting point. All right. Oh, I'm going to have to change that I may have to change that as well. Okay. So if there's no endpoint, then there is really no starting point. So I'm going to need to add this. So let me see here. If I had an endpoint, I need to find a starting point. I may have to do some extra stuff in here. So I have a starting point. I need to set start p and then to add node. Okay, and that should be fine. What else I'm going to need to do? When I set the start, I should have what's going to end up happening is I'm going to have to set my end. I could do that right here. So p end is equal to p to add node. That might make my life easier. Okay, so I know that there's only all right. That's what I'm doing here. I'm setting the starting point and then I'm doing the end. Make my life easier. Okay, so I need to worry about the set previous. I don't know what's going on with this. It's a double linked list node. Set previous should be working. I don't know why it's not. So let's see if I can. I'll worry about those in a second. Remove from the front. Okay, is my thing empty? I can check that fairly easily. If it's empty, well, I'm not doing anything. Otherwise, if I'm removing from the front, I need to call get start. It's going to be a doubly linked list node. That'll fix that thing. Insert it back. All right. So I need to get the start. Let's actually make this as a separate thing. So DLL. Because I know it's going to be a doubly linked list node no matter what, I might as well just cast it to a doubly linked list node each and every time. We'll see something better than doing this later on, because if this looks ugly, you have a good instinct. Okay, so what I need here is, this is just the starting to delete. This is an element I'm going to be deleting, and then this, I'm going to get the next element from the start. That's still fine. And I want to I might probably have to cast a bunch of stuff here. So DLL node. All right. So this is going to be the next is going to be a DLL node. This is going to be a DLL node. My set start p next. I'm going to now delete the thing I'm pointing to, and I'm done. Well, I would be done, but I need to also worry about what the next is pointing to. So the next should now be pointing to nothing. I'm getting rid of, so I have a start, I have a next. The next is now should be pointing to nothing at all. It's not pointing to that previous node. The previous node is about to be deleted. So I'm going to have p next set previous. I still don't know why it's not happy with that sort of thing. And I'm just going to set the previous. And I know DLL nodes this should work. So I'm going to get rid of the pointer to the previous and get rid of that node that I had. All right, removing from the back, I need to check out to see if I have one element, if I have 0 elements, that sort of thing. So now this one might be a little odd. So let's see if I can think it through before I start coding. Removing from the back, I need to go. I know I'm dealing with a doubly linked list. I know I have a previous for every single one of my linked list nodes. So if I just jump to the end, the final element, if I have a final element, I just go back one step and I can just pull. I don't have to walk down my array, my linked list at all. I just need to find the very last element, go back one step, update what my endpoint was, and I'm good to go. That's exactly what I don't even need the start anymore. So I want to just get the end. So if p end, so if there is no end, oh, if it's empty, I've already done that case. So we're asserting, we can even do an assertion here, p end, right? I'm asserting that this is that there is an endpoint. If there's not an endpoint, it shouldn't, if I don't have if the endpoint is null, then it should be empty. Otherwise, something happened somewhere in my code. I have a bug somewhere and I want to find it right away. Hence, I have an assertion, right? It should never be the case that this is ever false. If it's empty, I would have hit this case here. If it's not empty and I'm here, then I should have an endpoint. And if I don't, I need to find it right away. I got to find my bug right away. Okay, I get my endpoint. I'm going to get the previous to my endpoint. So DLL node previous end, like let's call it, is equal to p and get previous. I don't know why this previous stuff is not actually working at all, so we're going to find out. We'll find out soon enough. So I'm going to get the previous node. If there is a previous node, previous end, if there is a previous node, then I want to p end is equal to p previous end. I need to keep track of what the old previous was. Let's call it old end is equal to p end. Otherwise, I update where I'm pointing to the end position, the second last element. I say p previous and set next, and I'm going to set it to null, right? This thing is not pointed to anything. It's at the end of my array, and now will need to just delete p old end, and that should do it for me if I have a previous. And if I don't have a previous, it means I have exactly one element. So I can then return true. And if I have a thing with exactly one element, that means then I am just going to um, so otherwise, so I don't even need to do this test anymore. P end is equal to um, let's go this way. Delete p end is equal to null. Uh, this dot set start. I have no elements whatsoever anymore. I had one element and I'm getting rid of all connections to it and deleting the node. And that should do it for my entire thing. Return true. There you go. So I deleted the start and the end because I know that there's nothing in there. This is the one element that I have. I'm removing it. Is empty. I don't need to do this at all anymore, so I can get rid of that. That function already works. I'm going to comment out this particular function. I'm commenting it out for a very good reason. So please bear with me. Let's compile it. Let's see what the heck's going wrong with this thing. Okay. LN inheritance, line to this line. I want to see what's going on here. DLL node. And is it because it's a constant? In class code, DLL node is inaccessible. Okay, there we go. That's probably what the problem is. Okay, class LL node. This should be accessible. I need to figure out what the heck's going wrong with this, so I'm just going to walk on through this. So DLL node is going to have LL node.h. DLL node has this, has these variables. Why is it that cannot access private member declared in doubly linked list? So let's look at. So remember, I don't know where my bug is going to be, so I should go all the way to the very top here. Okay, doubly linked list.h is inaccessible. There you go. It's doubly linked list, sorry. Here's linked list.h, doubly linked list.h, pragable once. Doubly linked list is public linked list. I have doubly linked list here. I have public private. I have a semicolon at the end. That should all work. I have linked list.h. And that's going to be using the same sort of thing. I just want to see what the heck could be causing this particular problem. So I have a bunch of doubly linked lists everywhere. Doubly linked list, doubly linked list, doubly linked list. I can actually just highlight all of them. Doubly linked list, doubly linked list, doubly linked list. That should be fine. I want to look at doubly linked list.h. It's for public doubly linked list. Linked list, linked list. That should all be fine. I probably have something really stupid in here somewhere. Including, it could just be order of operations. I got to find out what the private member variable is. So it has doubly linked list. I'm making the doubly linked list. Let's look at this again. Oh, Okay, there you go. Found it. Let's look at my message. It says doubly linked list cannot access private member declared in class doubly linked list. So why is it private? It's actually not private. It's protected technically, but it's this thing. Protected, private. Oh, I forgot to put the word public, and that should fix its wagon. I also might need to do this with doubly linked list no, .h. Yep, I forgot that one too. These functions I want to have access to. Everyone should have access to them, so I need to make them public. I need to explicitly make them public. Otherwise, bad stuff's going to happen. Holy crap, it actually compiled. Okay, let's find out what's going to happen here. I have a doubly linked list here. I'm going to make a bunch of, this is going to make a bunch of doubly linked list nodes. They're going to be strung together. Here's hoping that it's going to all look fine. I have a way of printing out my doubly linked list. We're going to look at this in a bit more detail in a second, and I want to see doubly linked list.cpp. Let's see if I have any of we have that error with the get previous. So let's see if get previous. Oh, there it is. Set previous. It's no longer an error anymore. Why? Because it's now public. It's that function is now available to us. Okay, great. We got rid of our compilers, and notice it wasn't the thing that was being underlined. Set previous was already defined, but because things were being built incorrectly, because there was a mistake in the header file, it led to this cascading error. I got to fix the big error first at the very top, and then other errors automatically or magically fix themselves. And if I don't do that, I can get 400 errors and it's actually just one error. I had two errors there, and I had a list of like what 30 errors, something like that. Let's see what happens. We can always just find out. All right, we got a compiler. Great. Or an assertion failure. Okay, great. Is it empty? We're going to find we have something wrong here. There's my assertion failed. Let's have a look at this, the linked list. I have a linked list. There is no next. I have exactly one element. My end has not been updated. That's what happened. The p-end should be equal to p-start. When I remove something from the back or from the front, I need to make sure my p-end is updated. I don't know if my p-end is being updated ever. So if there's an endpoint, if there was an element previous to that, then I'm going to update my end to the previous end. Otherwise, I delete the end. I set it to null. I set my start to null. That's also fine. But if I have two, let me see here. If I have one element, it's probably not in this one. Let's see what the other possible case is. Because if I have exactly one element and I delete it, sorry, I have two elements and I delete it, what's going to happen? The next is going to the end is going to be whatever the previous one was, and that's correct. If I have exactly one element and I delete it, then the end should be equal to null. So that looks like it's going to be right. Then I must have some kind of problem with my remove from front. My start is this. Is it empty? No. I set my, so this is remove from front, right? So I set my previous to being null here. I set my start to be, I get my start. I get the next. I set the start to be equal to whatever the next is. And my end, if I had two elements, then my end would still be fine. Because if I have two elements, I don't need to update my end. If I have one element and I remove it, then I would need to update my end, but that's still fine. If this thing is, I'm removing that first element, whether it's null or not, it should be fine. So there's something weird going on here. It is, I also happen to know, if I look here, at my data structure. I know that the start is a legitimate point. The data is, maybe it's not a legitimate point. I have a next. My data is equal, num is equal to 0. I want to see, make sure that my this could be just a garbage pointer that I never cleaned up afterwards. So let's put a breakpoint in here. So here's my main method. Where is my main method? I'm just going to just jump over here and find it. There we go. Okay, I have a bunch of numbers here. One of the numbers actually ends up being 0. Let's make it 10, just so I know if I got a 0 in here somewhere. I'm going to insert a bunch of numbers. I'm going to print it off. I'm going to, the breakpoint, the right here, I want to put a breakpoint because I know removing from the front, removing from the back isn't really a problem. I should leave that alone. So right about now, I should have exactly one element. Then I call remove a bunch of times, and then I should have 0 elements. So I want to know if my error happens, where along this path it happens. So let's find out. All right, it's hitting the error before I get to my breakpoint. Good to know. Let's go to where my breakpoint is actually being called. Remove from back, it's a remove from back call. It's on this line here. It's remove from back. It's this line right here. Wow. Okay, before I even remove anything. So maybe when I'm inserting things, my back is not being updated. That's a possibility. So I want to see what this thing looks like. I'm going to put another breakpoint down. I'm going to run my code again. I'm now at this linked list. I'm going to dive on in. So I'm going to step into this function F11, and I'm going to see what I have. I have a start. I don't have a next. Something's going wrong with that next. And I do not have an end at all. Huh. We have something really weird going on with this doubly linked list. Because I should be able to, is it empty? No, it's not empty. I have a starting point. That starting point, though, just points to effectively nothing at all. There's nothing in the next. I have a feeling that when I added all these nodes, it wasn't adding correctly. These nodes were not being added correctly. So I'm going to go once again. Let's go into my LL main. I want to see what happens when I insert at the front, which functions I'm going to be calling. I have LL data being inserted everywhere. Let's see what's going to happen. Okay, LL should be, there's no endpoint. It's an empty array. If I step into this function, F11, I'm at insert at front. I have the data to add. I'm going to add the new node, make the new node. I'm going to get the start, which is equal to null. If the start is equal to null, then I want to set the start to being the null. Oh, I also did not update my endpoint when I inserted it at the front. I need to see, so one of the problems I'm going to have here is if I inserting at the back changes things, but if I insert it at the front and there was no starting point, I need to change my endpoint. My endpoint is only, I don't have to worry about my endpoint if there was no start to begin with. So well, I know this is going to be a problem, so else p and is equal to p to add node, right? So if I had a starting point, then I'm going to add to the front. But if I don't have a starting point, I know I don't have an endpoint either. So if there's no starting point, I'm going to set the start. I'm going to also set the endpoint, and that, at least that's not going to change all that much, but it's going to change some things. So let's walk into my function yet again, F11, to add. My starting point is equal to null, so I'm going to jump over this. I'm going to set my end to being equal to this. I'm going to set my start to be equal to my starting point. hopefully I can actually get access to that member variable. Notice my starting point. I have the this pointer has a linked list and the other parameter that I had here. So you can actually see that it's a linked list wrapped up with more stuff. That's what we're talking about with inheritance. We get the base class and then we wrap it up with more stuff. Here is my starting point. That seems fine. The next is equal to null. That's fine. And the previous is equal to this, and those two things are the same. All right. So far, so good. I'm going to go into the next one, see what happens here. So I have a start. I do have a legitimate start point. I have a node to add. So I'm going to add. I'm going to set the next. I'm going to set the start to equal the previous, and then I'm going to set the start to equal to this new node that I'm adding. And so thus my end and my start should look different now. My end and my start look different now based on this hex value. Great. So far so good. So I'm going to continue my code, see what I get at the end. Okay, now I'm at remove from back. So I've gone through all this inserting, all this printing. In fact, I can even see what the print looks like, calling DLL constructor node. The linked list at the end of all of this, after the first call to print, is 17, -2, 10. Whoa. I'm missing some stuff, I think, in my linked list. 17 and -2, 10 is the last number. Wait a second. I'm inserting at the end. Let's look at my thing. Insert it back. 3, 4, 5. I think I'm wiping out 3 and 4 with this 5. My insert at end that I made is not working as I expected. Okay, let's stop my code again. Let's see what might be the problem here. So I can either put a breakpoint at insert at end, or insert at back, sorry, or I could just figure out what's going on here. So I'm just going to put the breakpoint temporarily, but I'm probably going to I may not need it. Okay, wlinkList.cpp, I'm going to go insert at back. Okay, I'm going to make a new node that I'm going to add onto it. I figure out what the end point is. Great. If I have an endpoint, then I'm going to take my end, I'm going to set my next. Oh, that's the problem. I'm not updating where my endpoint is. Right? So here's what I'm doing. I have my endpoint. If I have an endpoint, I need to set the next to be this new node that I'm going to be adding. The new node should also be this new endpoint, my new endpoint. And I'm going to set the previous of the new node I'm adding to be what my previous endpoint was. So node 4, I add a fifth node. Node 4, it was the endpoint. It's now going to be pointing to the new endpoint, which is node 5, and node 5 then also has to point back to the previous, which is node 4. If there is no elements yet, then what I need to do is I figure out what the start point, so if there is no endpoint yet, I need to set the start, I need to set the end. They're both going to be pointing to this thing. I have a single element. Okay, so not remembering an endpoint, I don't know why that would still be so not updating my endpoint. I'm not sure why that would be so problematic, but it could be the problem. Set the previous, set the my endpoint, I'm setting to the next. All right, let's give that a go and see what happens. I'm gonna hit that breakpoint though, just to see it in action. Okay, F11. Let's walk into it. I'm going to make a brand new node. I'm going to get my my endpoint, my previous endpoint, or my older endpoint, which is 00CD06C8. Okay. I am now going to I'm going to set my endpoint, set the next to this new node. I'm going to set the new node and set it the previous to the endpoint. So I can look at both of these things, and my previous node, the thing I'm adding, it's going to be pointing to CD06C8. The endpoint is CD06C8. The previous that it's pointing to is CD05. It's another previous node. That's fine. Its next node should be this new node I'm adding, CD0310, CD0310. These two, they're the same. Great. And my endpoint is 068, and now it should be the new node I'm going to be adding. Okay, and then that should do it, but I don't know why my print methods are working the way they are. So we're just going to keep going, and let's see what I get at the end. 17 to negative 2, 10. Why is it that when I'm adding the new nodes, it's not... It seems to be stomping on my old nodes, but inserting at the front works just fine. The N10 is actually just stomping on my old nodes. It's because, unless what's happening is the 2 is then hooking on to this the N10, not the the negative 2 is hooking on to the N10 instead of the negative 2 hooking on to the whatever my data 3 was, my data 4 was, and my data 5 was. So I want to have a quick look at this thing here. Let's put another breakpoint to the line below. Let's cancel this. So I've inserted my data. I have my linked list. My linked list has a start point and an end point. My start point consists of 17, negative 2, 9 after 3 steps. P-end consists of the value negative 2. Oh boy. Okay. So that might be what my problem is. My endpoint, after doing that, let's go back one step. My endpoint, though, I insert at the front, I insert at the front, I insert at the back the value, should be inserting the value 9. I do have the value 9. I go, it's 17, negative 2, 9. But according to this, the endpoint that I have here, that says it's the endpoint, is negative 2. Something wonky is going on here. I have a bug in here. I got to figure out what that bug is. When I added to the back, my endpoint did not get updated correctly. I want to do another breakpoint back where I was before. Let's see what happens. Okay. So I should have, at this stage, I should have 17, negative 2. I haven't added the 9 yet. I'm going to add the 9, but I should have 17 and negative 2. So my values right now is 17 and negative 2 is the next. So 17, negative 2. Great. When I add the endpoint, should also be, my endpoint should be pointing to negative 2, right? Great. Except for the negative 2 doesn't have a previous. Does it? So here's the previous for the my endpoint. The previous for my, okay, it does have a previous, and it's 17. Okay, so negative 2, 17. If I'm going the other way, it's 17, negative 2 if I'm, for next. Okay, so far this is actually looking good. I'm adding this new data, this new number 9, and I need to see what's wrong with this. So I'm going to dive into my particular function. I'm going to walk down a bit further, and I'm going to see, okay, so I'm adding a new node with the value 9. It has no previous and no next. That's this thing right here. Value 9, no previous, no next. Fine. I'm going to find my endpoint, which should be the value have the value negative 2 in it. If I open this up, it should be the value negative 2 in it. Great. I'm going to see what the end, I'm going to set the next to point to this new thing. So my endpoint, my new endpoint should actually be, so here's my linked list node, it's -2, right? It should now be pointing, I have a next, which is now the value 9. I'm going to add this so that it points to the -2. We've already gone over those two things. And then I need to update pend, which is now pointing at -2. I need to update pend so that it's now this new node here. I don't know what the heck could be wrong with this unless, oh god. um, Remember this issue that we had? Every once in a while, everyone does stupid little mistakes. We have an endpoint. I need to get the endpoint. My doubly linked list, though, has a member variable called end. I should not be using this particular endpoint. I should just be using the member variable. There is no need for this line whatsoever right here. What's more important, though, is I have a member variable named pend. I have a local variable named pend. I'm changing my variables, thinking I'm changing the member variables right here, here, and here, but I'm actually just changing a local variable. I have not updated my actual member variable, which is what I needed to do in the first place. As a result, I actually just, so if I get rid of this one line here, which I didn't actually need, I don't think, it should, I was trying to go through another method, we should have it all work hunky-dory. Let's have a look again at what happens. So let's turn this off, let's continue, let's see what my code looks like. And now I have all the variables. I was modifying pend, the local variable pend, not the member variable pend. And by the way, if you want to never use the same name for local variables and member variables, be my guest. It's probably a safer maneuver, right? I was modifying a local variable instead of the member variable, but I did not know I was doing that because it's so easy to overlook that one line at the top. That's the kind of crap we have to go through as computer scientists, as programmers, as software engineers, whatever you're going to end up getting into. And this is the kind of little frustrations, or big frustrations you're going to get into. Okay, I want to see what remove from back looks like. So I'm going to go one step, see what happens. And remove another one from the back. And let's do the printout. Let's see what that looks like. So I should remove the 10 and the 21. Oh, is it remove from front? Okay, so I remove the 17 and the 10. So far, so good. Remove from back another time, and remove from back. So I should get rid of the 21 and the 9. Oh, need to be focused over here. All right, and I print it off and see what happens. That gives me a 2. That's exactly what I would expect. If I remove from the front again, I get an assertion error. Okay, so what's going on here? Exception thrown, right access violation. This previous that I have here, this is actually null. Wait, what? Why is my thing null? So remove from front. So I am in doubly linked list. I have this thing right here. So let's have a look at it. I have a linked list. I have exactly one element. I have no previous, or the end is actually the same thing. It's one of the same. The start and the end are the same. So this, I can set the start to be, this would be setting the start to null. And if that's where my problem is, okay, so now I'm going to go, this is my call, what's called my call stack. I can go from main, which then goes to remove from front, which then calls set start, which is where I have my problem. Actually, why is it set previous is the problem? Oh, set previous. This is the line that's the problem. Right? I am in this particular function. So I'm going to set the previous for this next node that I'm dealing with. Oh, I need to check to see if the next is actually null or not. If it is null, then I need to set that. Okay, this is just a simple, what would be a relatively simple null pointer exception. So if p next, or let's make it a bit more explicit just to make sure it's easier to understand, is not, as long as it's not equal to null, I'm going to set this. Otherwise, I'm not going to do squat. If the next that I get is null, like I have a single element, then I cannot set the previous. There's no previous to set. I'm going to set the start to be equal whatever the next is, and if that's null, so be it. I'm going to delete the node that I'm dealing with. I might need to set the end as well. So if there is no next, so this is removed from front. If there is no next, so if there's a next one, then I don't want to change my end. But otherwise, this dot set end. Oh, I just say p end is equal to no, right? If I have no other elements, we hit that particular case. Okay, and then I set my starting position. I delete the thing and I return true. Removing from the back, I check this one. I check to see if there is a previous. If there is a previous, otherwise, if there is a previous, then I do some other stuff. Otherwise, I delete the end. I set the end to. I go to return as well. I set the end to null. I set the start to null. Okay, so that, I think this situation is covered in the other scenario. I just made a little change. I'm going to see what happens. All right, I'm going to run it. Let's just see if I can run the whole thing. Great, my list is empty. It's exactly what I expected it to be. I'm going to do something else a little bit strange though, because I'm not sure about this. I'm removing from front. I'm going to remove from back for a couple of times, and let's see what happens here. Oh. Let's see if my remove from back causes any kind of problems. Just in case, I want to test my code. All right, I'm going to continue, and nope, seems to be just fine. All right, so I can just comment this out, leave put in my old code again. Great. All of this, and you're probably wondering what's the real benefit here? I mean, I had to rewrite a lot of my code in other parts. Yeah, but I didn't have to rewrite all of my code. In fact, the printing out of my linked list has not changed. I got to reuse that. Getting the previous did not change, did not have to redo this. Is empty, did not change, did not have to redo this. It's only when I was adding and removing elements where things got a little bit wonky, and then I had to actually add my own code. The DLL node thing, I mean, look how lazy I am with this thing. I added a constructor call because I wanted to see this in action. I added a previous call because I need to do a little bit of bookkeeping. But I don't have to do all of the other stuff that I did with the linked list node, right? I only dealt with the brand new variable that I had. I only had to add a new thing called get previous. I didn't have to do set previous or anything like that, although I could have. I don't have to do remotely as much code as I had with the original thing. I'd write it once the first time, reuse as much code as possible. That's what we're aiming for. Now I want to point out one other thing this has been a very long video and I apologize. I want to point out one other thing. Remember I added all these cout statements everywhere. So when I made something or I deleted something, I had a call saying, hey, this is the order of things that are happening. Let's look at this. So when I make a linked list, when I make a doubly linked list, I want to see, when do I call the constructor for doubly linked list? Do I even call the constructor for linked list, right? The parent class. When do I call the parent class? For the destructor, when do I call the destructor for a doubly linked list? When do I call the destructor for linked list? They are child and parents. So let's have a quick look at this in action, because it'll hopefully, I can get rid of that breakpoint. I'm calling my doubly linked list constructor. I make a bunch of nodes, fine. Oh, I need to add the calling linked list constructor. I add the destructor stuff in there already. Notice calling doubly linked list destructor, calling linked list just destructor afterwards. So the child class destructor gets called, then the parent class destructor gets called. I'm going to do it one more time. I'm going to add a comment, a message for my linked list constructor. Linked list constructor. So let's throw this up there. I'm going to do it after I've made all my variables, just calling linked list. All right, let's compile this again, see what happens. All right, so what's going to happen here? I'm going to call, and what I could also do is just do all this and not do the remove from front everywhere. And what should happen is I should be cleaning up all of those nodes one after the other. So I can also test that code, but we'll do this first. Hopefully this is going to work. Let's just rerun it, recompile and rerun it again. Because this shouldn't cause any kind of problems whatsoever. Linked list, calling linked list constructor. I have no idea why that suddenly got so slow. It can't cause an infinite loop. What's going on here? Okay, so I have my linked list node. Something weird's going on here. Why on earth is that suddenly going slow to no end? I'm going to just do a clean build. By the way, in case you ever get stuck and you don't know what happens, you can clean your solution. You can rebuild the entire solution. You can rebuild it all in case you think there's something that's a little bit wonky, right? If something happens that you're not sure what's going on here, you can try doing that. But that still might be a big problem somewhere along the lines. So let's go to my linked list main, put my breakpoint back down in here. Let's stop this. Let's maybe put a thing here. Something very strange is happening here, and I don't know what I did. Possibly could have done. I added one line of code. I didn't change squat. So this, and I got rid of that one line of code, so I don't know what's going on here. Let's see. It's up to date, inheritance, directory. Yes, this is yet another example of what you need to do when you're trying out things. P start is equal to null. Here's my linked list. Linked list main takes this, does all this kind of stuff. Okay, I can let's see. I'm going to clean the whole thing. I'm going to build it again. Notice it's going to be a bit slower, and if you're talking about a big project, you don't want to do this unless you really know there's something weird going on. Is there anything else that I'm missing? Possibly missing. I may have to stop the video just to debug this thing, because this is a weird thing going on here. Let me stop the video for a second because I didn't change anything in that last second. And what I'm going to do when we come back is we're going to look at the order in which constructors and destructors are being called. That's the whole point of what I was trying to show you. And for some reason, one little cout statement broke everything. So let's have a look. I'll take a little break. I'll come back and we'll see what happened.